This is pre-calculus section 5.3, solving trig equations, part number 2. And we'll start off with a relatively straightforward one. Once again, we want to solve this on the domain from 0 to 2 pi. We have a bracket with a 0, parentheses with the 2 pi. In other words, if the answer is 0, we don't also include 2 pi. Their answers are equivalent, but we're not going to include both of them because of the brackets versus parentheses. Okay, so jumping into this problem then. The first thing that we would do is divide both sides by 2. And so now we have this. I am interpreting this one. The sign is positive, which means it's either quadrant 1 or quadrant 2. In the first quadrant, I'll draw a reference angle. An angle is 60 degrees or pi over 3. So one of our answers is pi over 3. And then we'll go to the second quadrant, use that same reference angle, and that second answer then is going to be 2 pi over 3. Those are our two answers to this problem. And we're going to compare this problem directly with the next one. The problem we just worked on was sine of x, and this one is sine of 4x. So we'll start it the same way in that we will divide both sides by 2, and then we'll start solving for 4x. Because of the work that we just did, we know that one of the answers was pi over 3, and in the second quadrant we had another answer of 2 pi over 3. But here's where things start to get a little bit different. The 4x is going to be significant for us, because it's not just x equals, it's 4x equals. So if we divide the left side by 4 and divide the right side by 4, we get one answer of x equals pi over 12. And if we divide the right side of this one by 4 as well, we get 2 pi over 12, which simplifies down to pi over 6. Now, both of these answers are quite a bit less than 2 pi. And what I'm going to say is, because this number affecting the period is bigger, we're going to have 4 times as many answers as normal. If it was a 3x, we'd have 3 times as many answers as normal. To find those other answers, what we're going to do is go back to where we found these first solutions. If I add 2 pi onto that one, that would be 7 pi over 3. If we add 2 pi onto that one, then that one is 8 pi over 3. Then divide those answers by 4 to go from 4x to x, and we get 7 pi over 12. And the next one would be 8 pi over 12, which simplifies to 2 pi over 3. I know I need 4 times as many answers. I've got twice as many answers right now, so we need to find more. So to find the next set, add 2 pi on again. 13 pi over 3 and 14 pi over 3. Adding 2 pi onto those. And then when we solve those, we're going to have an answer of 13 pi over 12 and 14 pi over 12, which simplifies to 7 pi over 6. Go one more time, add 2 pi on again. That's 19 pi over 3, and also 20 pi over 3. And if we carry those down, that's answers of 19 pi over 12 and also 20 pi over 12, which simplifies to 5 pi over 3. I think that's all my answers. Normally we had 2 answers, and now I have 8 answers written. If I tried to go further, in other words, if I add 2 pi onto that one again, that's 25 pi over 3. If we divide that by 4, we get 25 pi over 12, and that's bigger than 2 pi, so it doesn't work. I did have all of my correct answers before. These are all of the solutions to that problem. Here's our next example, and in this one we have the trig function tangent, but there's one angle of 3x, another angle of tangent of x, so I don't want to try to combine those into one function together because those angles are different. Don't try to say this is tangent squared or something. With different angles, we're not going to try to multiply them together. However, both of these individual parts are multiplied by each other and equal to 0. So we're going to treat it just like any other equation when we have it factored and equal to 0. In other words, I'm going to take this first part, set it equal to 0, and then try to solve it. So what I'm trying to figure out, where is the tangent equal to 0? Well, tangent is sine over cosine. Tangent is equal to 0 anywhere that the sine equals 0. So I have 0 and pi. And because of the 3x in there, I know I have more answers than normal. Normally on the period from 0 to 2 pi, there's only 2 places where the tangent is equal to 0. However, in this case, we're going to multiply those, or add 2 pi onto them. So 2 pi 3 pi, 4 pi, and 5 pi, so that when we solve these, divide everything by 0, we get answers of 0, pi over 3, 2 pi over 3, pi, 4 pi over 3, and also 5 pi over 3. So these are all answers that work, because if it works for this first part, if it makes this first part equal to 0, 0 times whatever the second part is 0. So we have these solutions so far. Now for the other part. In this one we have tangent of x plus 1 equals 0. Subtract 1 from both sides. Tangent of x equals negative 1. So where does this work? Where is sine over cosine equal to negative 1? Well, it's going to be any place where sine and cosine are the same. And so I'm thinking a reference angle of pi over 4. And where is tangent negative? Tangent is negative in the second quadrant as well as the fourth quadrant. So if we go into that second quadrant, that answer is going to be 3 pi over 4. And if we looked at the answer down in the fourth quadrant, that answer is going to be 7 pi over 4. And note on this one, because this second angle was just x, it wasn't 2x, I don't have to worry about adding onto these and finding additional answers. Those are the only answers that are going to work for that second part. This is going to be the last example for this section. And observation, we only have one angle. That angle is x. There are two different trig functions. There's a secant squared and also a plain old tangent. I could get everything in terms of sine and cosine, but I recognize something else here. And that is that there is a Pythagorean identity that relates these together. In other words, secant squared could be substituted as 1 plus the tangent squared. And by making that substitution right away, I've saved myself some work, and I've got the only trig function in here is tangent. Subtract 1 from both sides, and here is the equation that we're looking to solve. This is equivalent to the original, but it definitely is simpler. As I'm looking to solve this one, I'm going to factor out a GCF on the left, and that GCF is the tangent. Factor it out of both of those terms, and we get this. So now we can start solving these different equations. First one, we want to figure out where does the tangent of x equal 0. So as I'm thinking about that, tangent is sine over cosine. The tangent is 0 anywhere the sine is 0. So I'm getting an answer at 0 and also at pi. And then it would occur again at 2 pi, but we're not going to include that one because of our restrictions on the domain. The other one, we're saying, where does tangent of x plus 0.5 equal 0? Or to simplify it more, where does the tangent of x equal negative 0.5? Now as I consider this one, tangent is negative in the second quadrant as well as in the fourth quadrant. But there is no special value for this one. Of all the ones we know with 30 degrees, 45 degrees, 60 degrees, or the radian equivalents, there is no fraction where sine over cosine reduces down to this. So this one is going to be a decimal problem. On my calculator, what I'm going to do is take the tangent inverse of 0.5, and I want to make sure that I'm in radian mode. And what I'm getting on the calculator is approximately 0.46. 0.46 radians in the first quadrant. I'm going to use that to help me figure out the answers that I really want. So if I take that reference angle and put it into the second quadrant, that means we're going to do pi minus that value and get about 2.68. 2.68 radians is going to be one of our solutions. The other solution will come out of the fourth quadrant. So if we put a reference angle down there, draw what it looks like, it's almost a full revolution of 2 pi, but it's actually going to be 2 pi minus that 0.46 reference angle that we talked about earlier, and this gives us another answer of 5.82 radians. So the first time we've had some approximate ones, and the reasons why we had to go approximate is because this is not going to be an exact value for us. So we ignored the negative temporarily to find our reference angle in the first quadrant. We considered the quadrants where the tangent was negative, and then we drew those in those quadrants to come up with the answers that work. So this is the end of section 5.3.